Hi everyone, welcome back to PolyCloud YouTube channel. In this series, we are learning everything you need to become a Red Hat certified system administrator, that is RHCSA. Whether you are just starting with Linux or preparing for certification exam, this video will guide you step by step, completely free of cost. In this complete series, we will cover understanding and using essential Linux tool, managing software and system services, configuring storage and file system along with managing user group and network and security and a lot more. Everything will be explained clearly with hands-on demos. This is 100% free end-to-end learning series, and I will bring many more such courses on Linux, Azure and cloud technology in coming months. So please support the channel by subscribing and helping us to reach our first 1000 subscriber goal. It really motivates me to keep creating free learning content for you. Currently, Azure 104 series is going on the channel, and also this Red Hat series is going on. So let's get started and master Linux one topic at a time right here on PolyCloud.
Welcome to this course on shell scripting. This course focuses on automating system administration tasks through Linux shell scripting. From writing basic scripts to using variables, conditionals, and debugging techniques, you'll gain the skills to create reliable automation solutions, which is an essential capability for RHCSA certification and efficient Linux system management. In this course, we will discover the power and key benefits of shell scripting, its practical uses in daily tasks, and why it is essential for efficient Linux automation. We will learn how to create a basic shell script, work with variables effectively, and use conditional statements to build logical flows. Next, we will explore testing scripts thoroughly and debugging common errors step by step. Then, we will examine advanced scripting methods, sharing valuable tips and techniques to write more efficient and robust shell scripts. Finally, we will implement a log output with accurate timestamps for effective tracking and troubleshooting. In this video, we will discuss shell scripting, its uses, why it is so powerful, and the benefits of learning shell scripting. Let's start with a simple thought. What if your computer could follow a list of instructions without you having to type every single command again and again? That's basically what shell scripting is all about. It's like writing a recipe for your computer. Once you write it, the computer can cook up that same result anytime you want, without asking questions. If you've ever worked with Linux or are preparing for RHCSA, you'll quickly see how helpful shell scripting can be. It saves time, reduces errors, and gives you control over tasks that might otherwise take hours to complete manually. What exactly is a shell? Before we dive into shell scripting, it's helpful to understand the term shell. In Linux, the shell is the place where you type commands. Think of it as the middleman between you and the computer's brain. You tell the shell what you want, and it passes the message to the system. There are different types of shells. Bash is the most common one, especially on RHEL systems. Others include SH, ZSH, and KSH, but Bash is where most beginners start, and it's excellent for scripting too. So what is shell scripting then? Shell scripting involves writing a series of shell commands in a file, allowing you to run them all together. This file is called a script and typically ends with .sh. Instead of typing one command, hitting enter, then the next, and so on, you just put everything in a script and run it like this. /myscript.sh. That's it. You write it once, and it can work 100 times the same way. Let's discuss why people use shell scripts. Now here's where it gets interesting. Shell scripts can be used for many practical things, especially in system administration. Imagine you need to update software on 10 servers. Would you really want to type the same set of commands on all of them? Probably not. With shell scripting, you write the update steps once and run the script on each server. Some common tasks that people perform with shell scripts include automating backups, monitoring system logs, starting or stopping services, creating users, scheduling tasks, cleaning temporary files, and setting up software. Basically, if you can do it in the shell, you can put it in a script. Let's see what a basic script looks like. Let's say you want to write a simple script that shows the current date and lists all files in the home directory. Here's how that might look. #/bin/bash. Echo today is date. Echo files in your home directory. ls. That first line, #/bin/bash, is called a shebang. It tells the system which shell to use when running the script. Everything else is just regular shell commands such as echo to print, date to show the date, and ls to list files. When you save this as a .sh file and run it, it performs these tasks in that order. Let's discuss what makes scripting so powerful. Scripting gets really powerful when you add logic, like if-else conditions, loops, and variables. That means your script can make decisions based on what's happening. For example, you could write a script that checks if your internet is working. #/bin/bash. Ping c1google.com and /dev/null. If $eq0, then echo internet is working. Else, echo internet is down. Fine. Here, the script tries to ping Google. If it succeeds, it says the internet is working. If not, it tells you it's down. That kind of control is what makes shell scripting so valuable for real-world tasks. How does shell scripting benefit RHCSA and system administration jobs? If you're studying for RHCSA, scripting is not just an add-on, it's a real skill. As a system administrator, you'll often be asked to automate things, and shell scripting is usually the first tool you'll reach for. You might write scripts that check disk usage and send alerts, rotate log files, start up services after a reboot, and configure network settings. Shell scripting helps keep systems consistent. If you write one good script, it'll work the same way every time, whether it's on one server or 20. Let's understand the benefits of learning shell scripting. Learning shell scripting gives you confidence and control over your system. You stop fearing the command line and start using it like a toolbox. It saves you hours of work, helps prevent errors, and enables you to solve problems more quickly. Also, scripting skills transfer well. Once you understand shell scripting, it becomes easier to learn other types of scripting or automation tools like Python, Ansible, or Bash-based CI/CD workflows. So, shell scripting isn't about being a programmer. It's about working smarter, not harder. Whether you're managing systems, solving problems, or just learning Linux, writing scripts gives you a reliable way to repeat tasks without repeating effort. If you're serious about Linux or aiming for RHCSA, don't skip scripting. It's one of the most practical, real-world skills you can pick up, and once you start using it, you'll wonder how you ever managed without it. In this demonstration, we'll create and execute our first shell script in Red Hat Enterprise Linux. To begin, you need to open the terminal. So click on the Activities tab at the top left corner of the screen. Navigate to the options displayed below and click on the tab on the right. This will open the terminal window. Let's create a new shell script. To do this, we'll use the Nano text editor. So type nano, first script, then press enter. This command opens a new shell script file named firstscript.sh inside the Nano editor. Let's begin by typing the following line inside the Nano editor. #!bin/bash. This line specifies that the script should be interpreted using. Press enter to move to a new line. On this new line, type the following. Echo, within double quotes type, hello, this is my first shell script in RHEL 9.7. Press Ctrl X. When prompted with Save Modified Buffer, press Y to confirm. Then press enter to save the changes and exit the Nano editor. Our shell script is now successfully saved to the system. Next, we need to assign executable permission to the shell script file. To do that, type chmod plus x first script. Chmod changes file permissions, plus small x adds execute permission to the file. Firstscript.sh is the name of the file to which the permission is being applied. Then press enter. To execute the script, type the following command. /firstscript.sh. Press enter. You should notice the output. Hello, this is my first shell script in RHEL 9.6. Alternatively, you can also execute the shell script using the bash command. So type bash first script.sh, enter. This will produce the same output as, hello, this is my first shell script in RHEL 9.6, which shows successful execution of the script. And that's how you can create and execute your first shell script in Red Hat Enterprise Linux. In this demonstration, we will learn how to create variables and work with data in shell scripts on Red Hat Enterprise Linux. To begin, open the terminal. Click on the Activities tab at the top, then click on the terminal icon to open the terminal window. Now let's create a new script file to work with variables. Type the following command, nano variables.sh. Then press enter. Nano opens the nano text editor. Variables.sh is the name of the new shell script file. Inside the nano editor, type the following first line, hash, exclamation, /bin/bash. This is the shebang of the system to use the bash shell to run the script. Press enter to move to the next line. Now declare the first variable by typing name equals within double quotes type RHCL user. Press enter to go to the next line. Then type age equals 28. Here, name holds the value RHEL user. Age holds the value 28. To display these variables, use the echo command. Type echo within double quotes. Hello, my name is $name, and I am $age years old at a full stop. Here, echo prints the text to the terminal. $name references the value of the name variable. $age references the value of the age variable. This demonstrates how variables are declared and used in shell script. Now save and exit, press Ctrl X. When prompted with Save Modified Buffer, press Y to confirm. Then press Enter to save the script file and exit Nano. Next, let's try executing the shell script. But first, let's assign execute permission to the script. Type chmod plus x variables.sh. Then press Enter. Here, chmod changes file plus x adds execute permission to the file. Variables.sh is the script file name. Now execute the script by typing /variables. Then press Enter. The output will display, hello, my name is RHEL user, and I am 28 years old. And that concludes our demonstration on creating and working with variables in shell scripts on Red Hat Enterprise Linux. This demonstration will use conditional statements in shell scripting. To start, open the terminal. Click on the Activities tab corner of your screen. Then, click on the terminal icon from the options shown to open the terminal window. First, we are going to use the basic if statement, which checks a condition. If it is true, then the command block runs. Let's create a file using the nano editor. Type nano if_basic.sh, then press Enter. This command opens a new shell script file named if_basic.sh inside the nano editor. Inside the editor, type the following lines, hash, exclamation, /bin/bash. This specifies that the script should be interpreted using the bash shell. Enter to move to the next line and type echo within double quotes, enter a number, : This command displays the message, enter a number, on the screen. Press Enter again and type read num. This command waits for the user to type a number and stores it in a variable name. Then press Enter to navigate to the new line. Next, let's add a simple if condition. Type if open square bracket $num -gt 10 close square bracket. Press Enter. Type. Then, in the next line, press Tab and type echo within double quotes. Number is greater than 10. This part checks if the value stored in num is greater than 10. If it is, then it prints number is greater than 10 again and type f I. This marks the end of the if. Once you're done, press Ctrl X to exit. When prompted with Save Modified Buffer, press Y to confirm. Then press Enter to save the file and close Nano. Next, we need to grant execution permission to the script. In the terminal, type chmod plus x if_basic.sh. In this command, chmod is used to change file permissions. Plus x adds execute permission. If underscore basic.sh is the name of the script we want to make executable. Press Enter to run the command. Once the execution permission is granted, type /if underscore basic.sh. Then press Enter. The script prompts you to enter a number. For example, enter 20 and press Enter. You will see the message, number is greater than 10, displayed on the screen, confirming the script ran successfully. This is how we can use a basic if statement in shell scripting. Let's now clear the terminal for a fresh view. Now let's create a shell script file again. In the terminal, type nano teststatement.sh. Enter. This command opens a new shell script file named teststatement.sh inside the nano editor. Inside the editor, type the following lines: hash, exclamation, /bin, /bash. This specifies that the script should be interpreted using the bash shell. Now press Enter to move to the next line. Read -p, open double quotes. Enter your number, close double quotes, num. This command will prompt the user to enter a number and store it in a variable named num. Again, press Enter to navigate to the new line. Next, let's add a simple if-else condition. Type if, open square bracket, $num, -l, small, t, 10, close square bracket, semicolon, then echo within double quotes. $num is less than 10, semicolon. This part checks if the enter number. Now press Enter again and type else, echo within double quotes, $num is greater than 10, semicolon. Here, else handles all other cases. In this case, when the number is 10 or greater. Navigate to a next line and type small f, small I. This marks the end of the if statement. Once you're done, press Ctrl X with Save Modified Buffer. Press Y to confirm, then press Enter to save the file and close Nano. Next, we need to grant execution permission to the script. In the terminal, type chmod +x teststatements. In this command, chmod is used to change file permissions. +x adds execute permission. Teststatements.sh is the script file we want to make executable. Press Enter to run the command. Now the script has execution permission and can be run directly. Once the execution permission is granted, let's run the script. Type the following command: /teststatements.sh. Then the script will execute and prompt you to enter a number. For example, enter 5 and press Enter. You will see the message, 5 is less than 10, displayed on the screen, confirming the script ran successfully. Now press the up arrow key to recall the previous /teststatements.sh. Then press Enter. This time, enter the number 15 as input and press Enter. You will see the message, 15 is greater than 10, displayed in the output, confirming the conditional check. Let's clear the terminal again. Next, we're going to use the if-elif ladder, which is used for checking multiple conditions. Let's create a new file using the nano editor. Type nano if underscore elif.sh. Enter. This command opens a new shell script file named if underscore elif.sh. Inside the editor, type the following lines: hash, exclamation, /bin, /bash. Now press Enter. Usage equals $, open parenthesis, df/. Insert pipe operator, tail, -1, insert pipe operator again. awk. Within single quotes, open a pair of curly brace, then type print $5. Insert pipe operator, sed, within single quotes, type s/%// close parenthesis. This command calculates the disk usage percentage of the root file system and stores it in a variable named usage. Again, press Enter to navigate to the new line. Next, let's add the first condition. Type if, open square bracket, $usage, -lt, 50, close square bracket. Press Enter and type, then press Enter, then press the Tab key and type echo, within double quotes, type disk usage is under control, insert a period. This condition checks if the disk usage is less than 50%. If it is, it prints disk usage is under control. In the next line, type elif Inside square brackets, type dollar usage dash small lt 80 close square bracket. Press enter and type. Then press the tab key and type. Echo within double quotes, type. Disk usage is moderate. This condition checks if the disk usage is less than 80% but greater than or equal to 50% and prints disk usage is moderate. Press enter again and type. Else. Again, press enter, then press the tab key and type. Echo within double quotes, type. Disk usage is critical. Take action. This handles the remaining case where disk usage is 80% or higher and prints disk usage is critical. Take action, line, and type. Small fi. This marks the end of the if else statement. Once you're done, press Ctrl X to exit and press enter to save the file and close Nano. Next, we need to grant execution permission to the script. In the terminal, type chmod plus small x if underscore elif.sh. Run the command. Once the execution permission is granted, let's run the script. Type /if underscore elif.sh. The script will execute and display the disk usage status based on the current usage percentage. For example, if the disk usage is below 50%, it will display usage is under control. And that concludes our demonstration on using conditional statements in shell scripting. Demonstration. We'll use the set command to test and debug scripts in Red Hat Enterprise Linux. To get started, open the terminal. Click the activity corner of your screen. From the options below, click the terminal icon on the right. This will launch the terminal window. Let's create a new shell script file. In the terminal, type nano debug.sh. This opens a new shell script file named debug.sh in the Nano editor. Now type the following lines inside the editor. Hash, exclamation, /bin/bash. This line tells the system to run the script using the bash shell. To move to the next line, then type set -x. This turns on debug mode, which shows each command before it runs. Press enter again and type echo within double quotes. Type starting script. This will print a friendly message to let you know the script has started, and type mkdir/tmp/testdir. This creates a temporary directory named testdir inside /tmp. Press enter again and type rm-r/tmp/testdir. This removes that same directory, along with any files inside it. Finally, press enter and type set +x. This turns debug mode off, so the script stops showing every command before execution. Once you're done, press Ctrl X to file buffer, press Y to confirm, then press enter to save the file and close Nano. Next, we need to grant execution permission to the script. In the terminal, type chmod +x debug.sh. Chmod is used to change file permissions. +x adds execute permission. Debug.sh is the script file we want to make executable. Press enter to run the command. Now the script has execution permission and can be run directly. Type the following command /debug.sh. Then press script execute each command step by step because debug mode is enabled. First, it displays the message, starting script using the echo command. Next, it creates a temporary directory at /tmp/testdir using the mkdir command. Then, it immediately removes that directory with the rm-r command. Finally, it disables debug mode with set +x command. Let's clear the terminal now for a clean workspace. Now let's create another shell script file. Type nano debug1.sh. Center. This opens a new shell script file named debug1.sh in the Nano editor. Now type the following lines inside the editor. Hash, exclamation, /bin/bash. This line tells the system to run the script. Press enter to move to the next line, then type set -small small u, small o pipe fail. This makes the script safer. -small e exits immediately if a command fails. Dash small u treats unset variables as an error. Dash small o, pipe fail, makes pipelines fail if any command in them fails. Press enter again and type. Set minus small x. This enables again and type. Directory equals within double quotes. Type /tmp /test. Here we store the directory path in a variable called directory. Press enter again and type. mkdir dash small p within double quotes. Type $directory. This creates the directory, and with dash small p, it won't show an error if the directory already exists. Press enter to go to the next line and type cd within double quotes. Type $directory. This changes into the newly created. Press enter and type touch file1.txt. This creates an empty file named file1.txt. Press enter one more time and type echo within double quotes. Script completed. This prints a message confirming the script is finished. When done, press Ctrl X, save, and enter to exit Nano. Next, we need to give execution permission to the script. Type chmod plus small x debug1.s and press enter. Once the permission is granted, you can run the script. Type dot/debug1.s and press enter. You'll see that the directory /tmp/test is created using the mkdir command. The script then navigates into that directory with the cd command. Next, it creates a file named file1.txt inside the directory. Finally, it displays a message confirming the script has completed using the echo command. Now, let's navigate into the test directory to check if the file exists. Type cd/tmp/test, then press enter. You should now be inside the test directory. In the terminal prompt, you'll see something like root at John test. Next, type the command ls enter. In the output, you'll see that file1.txt is listed inside the test directory. This confirms that the script executed successfully and created the file as intended. And that concludes our demonstration on using the set command to test and debug scripts in Red Hat Enterprise Linux. In this video, we will discuss advanced scripting methods, tips, and techniques. What is advanced scripting really about? Once you're done with the basics of shell scripting, such as printing messages, setting up loops, or using simple if-else checks, it's natural to ask, what's next? That's where advanced scripting concepts come into play. These are not about learning fancier commands. They're about writing scripts that behave smartly, handle different situations, and feel like real programs rather than just a chain of commands. Advanced scripting involves creating efficient, readable, and reliable scripts that perform tasks with flexibility and logical control, ensuring seamless execution. It emphasizes structure, clarity, and the ability to handle a wide range of scenarios effectively. So, it starts with thinking like a script designer. At a basic level, a shell script just executes commands one after another. However, advanced scripting requires some planning. Before writing anything, you start thinking, what type of decisions does this script need to make? What kind of input should it accept? How do I make it very flexible for the future? This is where scripting becomes more like software development. You don't just write a one-off script. You create something that others can use too. So, logic becomes a significant part of scripting. At this level, logic is everything. You're not just saying, if this happens, do that. You're planning how your script should behave when something goes wrong or when conditions change. This is where you begin designing smarter scripts. You build decision trees. So, if the input is start, the script runs a service. If it's stop, it performs another action. And if the input is invalid, it shows a helpful menu. Your script can also support multiple outcomes by adapting its behavior based on the environment, such as checking disk space, available memory, or network status before proceeding. Finally, you include fail-safes, so if something goes wrong, the script doesn't crash. Instead, it recovers gracefully or provides valuable feedback to the user. This kind of logic helps make your script more intelligent and adaptable, especially in production environments. So, flow control becomes more refined. Advanced scripting often requires a clear flow of actions, and this is where structure is important. You may need to handle complex loops that include break and continue statements to control the flow of execution. Sometimes, you'll nest conditionals inside loops or loops inside conditionals to manage more advanced logic. Additionally, you can control script execution using flags or switches, allowing users to customize behavior based on their specific needs. It's not about adding more logic. It's about keeping the logic organized so your script doesn't become messy or confusing over time. You want it to be readable months later, even by someone else. Therefore, advanced scripts communicate more effectively with users. A well-designed script should be like a polite assistant. It shouldn't just do things quietly. It should inform the user of its actions, ask for input if something's unclear, and explain errors in a way that makes sense. This level of communication helps users trust the script. In enterprise environments, scripts often run automatically. However, even in these cases, logging serves as a form of communication. Good logs tell administrators what happened and when. Therefore, handling unexpected situations becomes essential. In real-world scripting, unexpected issues are common where files might be missing or network connections may fail. While a basic script might simply break and exit in such situations, an advanced script is designed to anticipate and handle these failures gracefully, ensuring the script remains robust and reliable. Here's what you think about. What happens if a file isn't found? What if the input is blank or invalid? What if a command fails? Handling these situations with clear messages or backup plans is what makes your script reliable, especially when used by teams or in production. Therefore, scalability and flexibility become the primary goals. In advanced scripting, you don't write for just one machine or one purpose anymore. You start designing for flexibility. These scripts should be capable of handling varying user inputs, accommodating different system environments with minimal adjustments, and adapting to changing configurations over time. You can allow environment variables, configuration files, or even command line flags to enable the script to adjust itself without requiring changes to the code. This is especially useful for system admins managing multiple servers or developers automating build systems. Your script should be one size fits many. Advanced scripting isn't about memorizing commands. It is all about strategy. You build scripts that anticipate future needs, handle errors gracefully, adapt to different requirements, and communicate with users. It's like turning your script into a lightweight tool or utility. When preparing for the RHCSA or working on real Linux systems, these advanced ideas help you build clean, reusable, and production-friendly scripts. You don't just automate tasks, you make them reliable, safe, and repeatable. Demonstration, we'll create a script that logs output with timestamps in Red Hat Enterprise Linux. To begin, open the terminal. Click the Activities tab at the top left corner of your screen. From the options below, click the terminal icon. This will open the terminal window. Now let's create a new script file. So type the following command: nano script. This opens the new script file, script.sh. Inside the editor, start by typing #bin/bash. This line tells the system to run the script using the bash shell. Press enter to move to the next type. Log, in capital letters, equals, within double quotes type, /temp/log.txt. This sets a variable called log that will store the path to our log file. Now we'll create a function named log that will log messages with a timestamp. It will take a message as input and append it to the log file, along with the current date and time. Press enter again and type log, open and close parenthesis, then open curly brace. Press enter to go to the next line. Echo, open double quotes, and type $, open parenthesis and type date, open single quote, then type plus, capital F, capital T, close single quote, close parenthesis, dash, $1, close double quotes, insert append operator, and within double quotes type $log. Here, $date plus percent, capital F, percent capital T gets the current date and time. $1 is the first argument passed to the log function. Append operator, $log appends the message to the log file. Press enter and close. This closes the function definition. Now let's start logging events with our script. Press enter to go to a new line and type log within double quotes type start. Press enter and type mkdir -small p /tmp /demo $& log within double quotes type created /tmp /demo. Press enter again and type touch /tmp /demo /file.txt log within double quotes type created file.txt. Press enter and type ls/tmp /demo insert append operator and within double quotes type $log. This lists the contents of /tmp /demo and appends the output to our log file. Press enter one last time and type log within double quotes type and when you're done, save and exit nano by then y and finally enter. Next, we'll give the script execute permission. Type the following command chmod +x script.sh. Press enter. Executable. Let's run it. /script.sh. Press enter. Any output in the terminal because all the messages are being logged into the file we created. To view the output, type the following command cat/temp/log. Press enter. In the output, you'll see log messages, each marked with a timestamp. And that concludes our demonstration on creating a script that logs output with timestamps in Red Hat Enterprise Linux. We explored the power and benefits of shell scripting, emphasizing its practical applications and importance in Linux automation. We learned how to create basic scripts, work with variables, and use conditional statements to build logic. We then examined effective script testing and debugging. Next, we explored advanced scripting techniques, sharing tips for writing more efficient, maintainable, and robust scripts. Finally, we implemented a log output with timestamps for better tracking.